Good morning, student. I am Dr. Ibha. In this video, I will be discussing about the correlation. First of all, correlation is a statistical techniques through which we can calculate the relationship between two variables. For example, price and demand. If the price of the product is increasing or if it is decreasing, how it will impact to the demand of that particular product, we can calculate these two variables, price and demand, or price and supply, or demand and supply. There are different variables are there where we can predict the relationship between two variables. If one variable is increasing, how it will impact to other variable. There are majorly two techniques are there to calculate the correlation. First one is Karl Pearson's coefficient of correlation, and second is Spearman rank correlation. In this video, I will be discussing about the Karl Pearson's coefficient of correlation. It is denoted as small r. Here you can see in the screen, I have shown you that format for the calculation of Karl Pearson's coefficient of correlation. So there are two variables I have written, x and y. It is x is the first variable. It can be anything. Production of the, if you're putting the fertilizer in crop, in cereals, how it will impact in the production of that particular cereals. That in things, two variables we are talking about here. The first variable here may be price, you can take, so it will be x variable. Second variable, demand, supply, whatever it is there in the questions, that you can write it. So x and y, two variables they will give you in the questions. Now we have to calculate the Karl Pearson's coefficient of correlation based on these two variables x and y. So this format you have to remember. So it is capital X, you can see, and I have written as in the second variable I have taken as a y. That is, now the formula of the Karl Pearson's coefficient of correlation, which is denoted as small r, is equal to summation of x into y divided by root square of summation of x square into summation of y square. So here you can look into that format. We know this now formula is this. So when we are calculating the Karl Pearson's coefficient of correlation, this format, if you will be remembered, it will be very easy to calculate the Karl Pearson's coefficient of correlation. So here I have taken that small x. In some places you can see they have written as dx also, or you can write it in small x also. So here I have used it, small x is equal to x minus x, the first variable, minus x average. So we have to calculate the average of x. Then y will be small y, which will be the difference of y variable and the average of y variable. Then we will multiply this first column, x small x into small y. Third column will be there. Then fourth column will be x square, and last column will be the y square. So this will be, we will be adding the value, summation of x, y we will be getting, summation of x squared we will be getting, summation of y square. Now x average, you know the mean of the x variable, we can calculate as summation of x divided by n, summation of x by adding all the values of x variable divided by the number of observation, and the same way we can calculate the average of y variable. So here in the next I have given one example and I will tell you how to calculate the Karl Pearson's coefficient of correlation. So here in the next, it is the question here. It is there. Calculate the Karl Pearson's coefficient of correlation between price and supply from the following data. So here the x variable and y variable is your price is x variable and y you can consider as supply here in this question. So x they have given, price was in rupees, 11 rupees to 11 to 19 they have given. The supply of the quantity, it is 30, 29, 29, 50. They have given some values in quantity of the supply. Now we got it the value of x as price, value of y, second variable y, that is the supply. Then the first we will calculate the average of x variable and average of y variable. How we will calculate? By adding all the price. There are total 10 price they have given when it was 11 rupees, 12 rupees till 19 rupees. So there are 10 price they have given you in the question. So total price we will calculate it. So 11 plus 12 plus 13 plus 20 plus all this till 19 divided by the number of observation. There are 10 observation they have given, 10 prices they have given you. So x average will be 155 divided by 10. That will come under the 15.5. The same way we have calculated for the average of y variable. It is 240 by 10, 24. So first of all, we will calculate the average of x variable and average of y variable. Then we will go to the format. That first column will indicate the small x, or in some places you can see it will be dx also. So small x will be x variable minus the average of x variable. So here 11 is first variable x. So 11 minus 15.5. 15.5 we have calculated as the average of x. So 11 minus 15.5 will give you minus 4.5. 12 minus 15.5 will give you minus 3.5. So the small x will be calculated. We will deduct all the variable of x with the average of x. Average of x in this question is 15.5. So 11 minus 15.5, 12 minus 15.5, 13 minus 15.5. It will be keep on coming minus 4.5, minus 3.5, minus 2.5. It will be this. So first column we got it, that is small x. The same way we will calculate the small y. That will be the difference of y variable minus average of y variable. So here y is 30 and we have calculated the average of y as 24. So 30 minus 24, the first you can see in y column, it is 6. Then 29 minus 24, it is 5. 29 minus 20 minus 24, it is 5. You can calculate the small x and the small y. The third column is x into y. So whatever we have calculated here, minus 4.5 multiplied by 6, y is 6. So minus 4.5 multiplied by 6 will give you minus 27. We have to consider the minus value when we are adding those value, or when we will calculate the summation of x, y. We have to consider the negative value as well. So the same way we will multiply all the small x variable with small y variable, and we will get it in the third column, that is x into y. So here we got it minus 27, minus 17.5, minus 12.5, minus 40.5, all we got it. At the last, you can see that in the format I told you that you have to calculate the summation of x into y. So summation of x into y, here if you will add all these values in this column, x into y column, you will be getting that minus 1 to 5. We got it. The next column is x square. The x variable, here you see that first column, small x variable, minus 4.5 into minus 4.5 will give you minus minus, it will give you plus value. So it is 20.25. The same way we have calculated related to all the variables, x square. The same way we will calculate again for y variable, that is y square. Here first y variable is minus 6. So 6 into 6 will be 36, 25, 25. Then we will add all the y square values and we got it 208. So now we got it with this format. We got it summation of x into y value as minus 125. Summation of x square is 82.5. Summation of y square is 208. Now put all these values in the formula of Karl-Pearson's coefficient of correlation, and the formula is R equal to summation of x into y divided by root of summation of x square into summation of y square. So summation of x into y we have calculated minus 1 to 5. So minus 1 to 5 divided by root of summation of x square, that is 82.5 multiplied by 208. So when we will get the value, we got it here minus 125 divided by root of 82.5 into 205. So we have calculated as R value. After the calculation, we got it minus 0.9542. So whenever it will be minus value, now always in the Karl-Pearson's coefficient of correlation, we have to interpret the value of R which we have got it. Here R is minus 0.9542. It means that if the price of the product will increase, supply will decrease, or vice versa. So always, if the positive relation, the value of R always will range from minus 1 to plus 1. Minus 1, if R is minus 1, it is perfectly negatively correlated. If R value is plus 1, it is perfectly positively correlated. So whenever Karl-Pearson's coefficient of correlation, you are doing the questions, you have to interpret the value of R. Here, as we got it that minus 0.95, it's near to 1. So it will be the correlation between price and supply is highly negatively correlated. So I hope you understood the Karl-Pearson's calculation of Karl-Pearson's coefficient of correlation. So next video, I'll be talking about maybe Spearman rank correlation or other statistical techniques. So thank you all. Bye-bye. Take care.